Okay, good morning, everyone. Welcome to the GISS Sea Level Rise seminar. We're very glad to have Dr. Miyuki Hino, who is an assistant professor in the Department of City and Regional Planning and an adjunct assistant professor in the Environment, Ecology, and Energy program at the University of North Carolina at Chapel Hill. She is an environmental social scientist working on measuring and managing the impacts of climate change, and her research examines the linkages between natural hazards, governance, and public policy to drive effective and equitable adaptation to climate change. Dr. Hino received her PhD from Stanford University's Emmett Interdisciplinary Program in Environment and Resources, and her BS in Chemical Engineering from Yale University. Before Stanford, she spent several years supporting evidence-based climate change adaptation and mitigation decision-making, most recently at the New Climate Economy and ICF International. And today she will be speaking on the topic incidence and impacts of chronic coastal flooding in North Carolina. Welcome.
Thanks. Well, thanks for the invitation. I will go ahead and share. Displays. Okay. I think that should be, yeah, that's right. Okay. Great. Well, thanks for the invitation. And I am excited to get to share a lot of this work with you today. We have been doing a lot of research here in North Carolina, all under the umbrella of the Sunny Day Flooding Project, but digging into lots of different aspects of the incidence of chronic coastal flooding and the associated impacts. My co-lead on this project is Dr. Catherine Anardi, who's in civil construction and environmental engineering at NC State. And so she has had a huge hand in a lot of this work as well. We also have lots of partners, both academic and non-academic. We work very closely with our town officials and community-based organization partners as well. You'll see a lot of these names and pictures pop up later on in the presentation, but definitely want to acknowledge that this has been a huge team effort. So, as many of you here today are very familiar with, we're seeing coastal flooding more and more often in the absence of extreme events due to sea level rise. And this is simply because coastal infrastructure was designed for a certain range of water levels. And with higher average sea levels, it no longer takes a storm to overtop a bulkhead or cause water to come up over onto the road. We're seeing this more and more often just with high tides. We tend to use tide gauge data to estimate how often this type of flooding is happening. So tide gauges, you can see in this schematic here, they are based out over a body of water. They're measuring the water level. And once the water level surpasses a certain threshold, we would call that a high tide flood day based on the tide gauge data. So it works quite well when you have high marine water levels that are, for example, pushing water back up into a stormwater drainage system and out onto the road. And those tide gauge data are what we use certainly at a national scale to think about how often flooding is happening outside of extreme events and how that might change moving forward. So here are NOAA projections for high tide flood frequency by decade out to the end of the 21st century, just looking at the Beaufort, North Carolina gauge. So you can see that regardless of what scenario we're in, we are projected to get an increase, an acceleration in the frequency of this type of flooding. In fact, in the intermediate to high scenarios, we're maxing out at 365 days a year by the end of the century. And we tend to rely on these tide gauge-based measures and the associated projections to think about what coastal residents might be experiencing now and in the future, and which places might be most in need of adaptation or flood response strategies. But Tide gauges are really not actually intended to capture all sources of flooding. So here in this diagram is a slightly different example of a flood. You have a moderate tide, so water that is not high enough to trigger a flood day based on the tide gauge, but it is high enough to impair the drainage system. So when you get rainfall, the rain has nowhere to go, and the road still does flood, even though the water level in the body of water is not that high. So tide gauges aren't designed to capture things like rainfall, high groundwater, faulty infrastructure. Tide gauges are also not located everywhere. So in North Carolina, we have 4 that we can really work off of for the types of statistics that NOAA produces. There are, of course, some urban areas that have a higher concentration, but rural areas that can really be quite distant from a tide gauge. We have much less data about what might be happening there. So these challenges with the tide gauge-based estimates drove us to ask this question of how often is it really flooding on land if what we want to capture is the experience of coastal residents, what's really happening on land, and what are the drivers of that flooding. So today I'll be talking through 3 kind of interlinked pieces of that. The first are results from a new sensor network that has been deployed in coastal North Carolina for coming almost 3 years now, and tailored local flood models we've built to go along with that sensor data. That will kind of be the bulk of this presentation because that's been kind of the longest coming and where we have most of our results. I'll also go into the impacts on coastal residents. That is coming from 2 different household survey efforts on the Carolina coast co-located with our sensors to understand the experience of coastal residents, as well as some water quality related research that has just been getting started in the past year. And then finally, I'll talk a little bit about some ongoing work working with communities to identify and evaluate adaptation measures. Okay, so starting with this first question of how often is it flooding on land? First, to be clear, when I'm talking about this type of chronic coastal flooding, I'm talking about small in spatial scale. So often it's a matter of a few city blocks or maybe even 1 city block. Also can be quite short in temporal scale. So we're talking minutes to hours, and then all sorts of flood drivers. So tides, wind, river, groundwater, infrastructure, rainfall. We are interested in when there's water on land due to whatever combination of drivers may have led to water pooling there. It's called high tide flooding, nuisance flooding, lots of different things. We're just calling it chronic coastal flooding for the purposes of our work and for the talk today. To measure this type of flooding, we developed a new sensor network here. And there's 2 pieces of it. The first is a pressure logger that sits in the storm drain. The pressure sensor is essentially at the bottom of the drain, so it starts to measure water as soon as it's pooling up back from the body of water, and will measure water depths all the way as the water rises up. The pressure logger talks to a communications gateway, which also includes a camera. So we're taking pictures of the road every 6 minutes and transmitting the water level reading and the picture in real time. And the advantage of this sensor network is that, yes, we do detect what people would call sunny day or maybe traditional high tide flooding when the water level in the ocean is very high. But we're also going to detect flooding when it's driven by land-based sources. And so when we have this type of event that might not get captured on the tide gauge, we are going to pick it up with our sensors anyway. This is what our sensors look like in real life. So here's the pressure sensor that's strapped to the grate. It will dangle down when you lower that grate. It dangles down into the bottom of the drain. And then it's communicating with this little box that's mounted on that pole, and the camera is in this box as well. And that's where we're getting pictures and then the water levels from in the drain. We currently have sensors out in 5 communities in North Carolina. Some of them have multiple sensors, and we've been rolling them out since 2021, sort of slowly, gradually expanding. And so today I'll be talking about 3 locations: Carolina Beach, which is our farthest south site, Beaufort, and Sea Level, which are actually relatively close to each other, but really different in terms of their physical and socioeconomic characteristics. So when we look at our data from the past year, so this is from April 7th, 2023 to April 8th, 2024, in Beaufort, we record 29 floods across 23 different days. In Carolina Beach, we record 69 floods across 63 days, and in Sea Level, 151 floods across 123 days. So that's literally one in 3 days of the past year where there was water on the road in Sea Level. We're calling a flood any amount of water on the road. So it does not have to be deep, and that's because this is saltwater, so there can be damage to vehicles and physical property, even if it's not very deep water. And we are not including floods associated with extreme events. So we go through and look at days that the National Weather Service identifies as a storm day, and we remove all of those from our data. So these are non-storm events where we're measuring water on the road. As I said, this is a pretty wide range of settings. And so we have Beaufort, which is more urban, has a stormwater network, is actually located very close to a NOAA tide gauge. They're within sight of one another, essentially, versus Sea Level, much more rural. There is no stormwater network. It's all ditches, and has much less flood data. So I'll be talking about kind of what we're learning from these different sites as it relates to the flood drivers, especially. To compare our numbers to these tide gauge-based estimates, we compare it to 2 different tide gauge-based estimates. One is from NOAA, so NOAA has a high tide flood threshold. Those are not intended to be calibrated to local impacts. Those are statistically defined. And the National Weather Service, NWS, also has thresholds that they use for minor flooding. Those are intended to be more impact-based because they're used to issue coastal flood advisories. So in Beaufort, you can see the NOAA count, the National Weather Service count, and then our count in dark blue. So we have many more floods recorded than the NOAA high tide flood count would indicate, actually fewer than the National Weather Service. In Carolina Beach, the nearest tide gauge is Wilmington, North Carolina. Wilmington, North Carolina surpassed the NOAA high tide flooding threshold just once. But the National Weather Service threshold is much lower. So there were over 150 days of surpassing that tide gauge threshold. And we're kind of right in the middle. We have about 60 days of flooding in Carolina Beach. And then in Sea Level, the closest gauge to Sea Level is Beaufort. So these 2 columns, the lighter columns, are the same for Beaufort and Sea Level. But we observe an order of magnitude more flood days in Sea Level than we do in Beaufort. So our estimates are consistently higher and significantly higher than the NOAA high tide flood counts. And the National Weather Service counts are a little bit harder to characterize whether those are higher or lower than what we're recording where we are. So to dig a little bit more into drivers, so first I'll focus on Beaufort. This is work led by Adam Gold when he was a postdoc at UNC. He's now at the Environmental Defense Fund. And what you see on the left is a sequence of photos from our Beaufort gauge from a flood in November 2021. The time series of water levels for that event is shown in the bottom right. And there's actually 2 lines on that graph. There's a dark blue line, which is the water level we're recording in this storm drain that you can see right where that traffic cone is. And then the pink line is the water level at the NOAA gauge. And again, these are very close to each other. So it's good for us to see when there's no rain, it's just a pure sunny day event. Those data match up very, very well. And we capture those events very well with the tide gauge data. One thing worth noting with this sequence of pictures is the water is bubbling up from the storm drain here. And so it's not actually overtopping the waterfront edge until very late in the sequence, but it does start much earlier than you would expect based on kind of the elevation of the coastal edge. So while the tide gauge captures the sunny day events well, it does not capture the rainy day events. So here, this time series, again, in pink is the NOAA observed water level, in black, our data. And where you have these spikes, these deviations, this is where we're seeing rainfall, and you can see that on the top panel. And this picture is taken right at this spike, essentially. It's hard to see because it's wet, but there's sort of a ring of water that you can make out in the middle of this image. It was clearly a very short-lived, it was not a very long-lasting flood, but we do see these flashier rain or compound events relatively often. So splitting between sunny and rainy day events, we did this for a different time period. So this was a 6-month stretch in 2021 where we looked at this. What you're looking at here is the cross section of the road. So these upper edges on the sides are the sidewalks, and then the road is the middle hump. And each line, each green and pink line, is a flood event that we documented over this time period. And the height of the line is the depth of the flood. Over this time period, 25% of our events were rainy day events, which again are not going to be captured by either of the tide gauge based proxies. So over this time period, we recorded, I believe, 24 events. 4 of those were also detected as above the NOAA high tide flooding threshold, and 8 of them were above the National Weather Service minor flood threshold. Okay, I'll now move to Carolina Beach, where we have Thomas Thelen, who's a PhD student with Catherine Nanardi, has developed a local flood model and validated against our sensor measures to decompose the drivers of flooding into their various components. So this is conditions from January 22nd, 2023, and the forcing is just the astronomical tides. And so you can see in this yellow box, we do get water at the north end of this, they call it the yacht basin. There's water pooling here, but it's pretty much confined to this yellow box. When you add wind forcing, again, the observed wind forcing on January 22nd, this is when you get higher water levels, and it pushes all the way down Canal Drive, running south to where we have a sensor. So what this looks like from our sensor, this is a different event, but gives you a sense of what it looks like when Canal Drive starts flooding. We get water running overland down the road, and actually gets relatively high quite quickly in this area. One thing we're working on now is, because we can't have sensors everywhere, we're trying to couple our sensors with remotely sensed data to detect these smaller floods, the extent and the frequency of these floods. So this is work led by Dr. Chao Wang and Dr. Tamlin Pavelski here at UNC. We are using X-band SAR, which is much higher resolution, as you can see on the left. And essentially tasking the satellite based on when we know or when we expect flooding to occur, and trying to see what we can recover from the radar data. This is very early stage work, so I'll just show a couple of our preliminary findings. Here are 4 different snapshots from just north of Carolina Beach, which is mostly marshy. And the right-hand image is low tide, so nothing is flooded. The water level's well below the road, so it's almost 3 feet below the road. And then the 3 panels on the left are flooded at different heights. And you can see very clearly, like the marsh footprint is totally different when it's flooded than when it's non-flooded. And so you have very good visibility of inundation in this area. But when we move south to the more urban developed part of Carolina Beach, it becomes much, much harder. And so this is, again, the non-flooded one on the right, and then the flooded ones are on the three on the left. And it's, it's just, we're talking about smaller, we have narrow roadways, we have houses, we have lots of changes in land cover over small spaces. And so we're still collecting new images whenever we have opportunities to task the satellite in to coincide with some of our flood windows, and are working on seeing what we can back out from this data in order to really scale where we can measure this type of flooding. Okay, so I'm trying to keep track of time here. Okay. For this question of how often is it flooding on land and what are the drivers, based on our measures of flood frequency on land, the tide gauge based proxies are really not capturing it well. And partly it's because tide gauges are not necessarily located where people are, where people can be very far from tide gauges, but it's also rain, stormwater infrastructure, and these land-based drivers that contribute to floods that wouldn't be observed in the marine water level. The mix of components does vary from place to place, so it's difficult for us to say how far off the gauge measures might be from one place to another, and especially as you move far away from gauges. Okay, I will shift now to thinking about the impacts on coastal residents. And here I'll be presenting results from two different household surveys. So the first household survey, we call it DEEP, the Dynamics of Extreme Events, People, and Places. It's led by Elizabeth Frankenberg here at UNC. And it samples respondents from 4 counties, so Craven, Carteret, and Hyde and Dare. Hyde and Dare are almost the entire Outer Banks of North Carolina. Most of our respondents have at some point, or the locations of our respondents have experienced at least a hurricane or extreme event flooding at some point, but we did not sample them with this type of chronic coastal flooding in mind. And so there's actually within our respondents quite a large amount of variation in terms of how far inland they are, and how close to the coast they are, and the elevation of their property. Having said all of that, when we look at our respondents, we ask them this question of, does their property ever flood outside of hurricane events? So again, trying to get away from these extreme events. Over 40% of our respondents say that some part of their property does experience flooding outside of hurricanes. It may not necessarily be their house, so it could be their backyard or it could be their garage, but it's still quite widespread, given that we didn't actually sample all of the lowest lying households in these various counties. We also ask about 4 different types of disruptions from flooding within the past year. So these all occurred more than a year after any hurricane hit the area. So we're definitely not capturing any hurricane-related disruptions in these results. And you can see, first, we ask, the sample size is different because we don't ask about disrupting school if the household doesn't have a school-aged child, for example. And about 15% of our respondents say that either getting to or coming back from school, the school schedule in some way was disrupted in the last year. But when it comes to disrupting commutes to work, ability to run errands, ability to have social activities, we're looking at 25 to 30% of our entire sample saying that they've experienced flooding-related disruptions to those things in the last year. We can split this up by county, which I think is interesting because the pattern varies across counties. Dare County, for example, more than 75% of our respondents in Dare County said that their property floods outside of hurricanes, and they're also quite high on all of the other measures. Craven County, which is our farthest inland location, relatively lower frequencies. But you do see, some places where school is perhaps more prevalent than the commute and so forth in terms of what the disruptions exactly are. So having seen some of this data, we then developed a more intensive a household survey that was really focused on chronic flooding and its impacts in Carolina Beach. And that we launched at the beginning of this year. So we sent a postcard that looks like this to every residential address in town, and we got over 350 completed responses over the 3 months at the start of this year. And so, as I said, we asked a lot more detailed questions about the disruptions from non-storm flooding that the residents of Carolina Beach had experienced. So here's our full list of things that we asked about. You can see things like trash collection disruptions. So when the street floods, trash bins get upended and float away. Or the garbage truck can't make it to the houses. And so that was a really widespread disruption. But you see perceptions, at least, of impacts of lots of different types. And so losing home value and rental income, neighbors moving out because of the flooding and either renting or selling their properties, of course, property and vehicle damage as well. And so there's a really wide range of impacts that these residents are already reporting. So another question we ask in this survey is, how likely are they to move to a less flood-prone place in Carolina Beach? So staying in town, but if they had the opportunity to move to a less flood-prone place, what's the likelihood that they would take it? And I'm dividing the respondents here based on how many impacts from flooding that they report. So if they said no to all of these things, then they're in this panel of 0 impacts. And so unsurprisingly for this set of folks who really don't report much flood impact at all, the vast majority of them are saying that they would not even consider moving to a place that was less flood prone in town, or maybe they think that that place doesn't even exist. The next panel here, these are people who report some disruptions. So 1 to 3, 1 to 3, they said yes to 1 to 3 of this long list of things. And here again, most people are saying no chance. So a little bit more in this, like there's a low likelihood, but it's non-zero. And now again, I'm adding now people who are, I would say, moderately or moderately high affected, 4 to 6 impact types. This bump is the 50% mark. So there's people saying, yeah, it's a 50-50 chance that they would leave. And then finally, people who are very affected, so 7 or more types of impacts from flooding. And here you actually see a much sharper shift to the right. The modal response here is a 40 to 60% chance of moving. And so you can see that interest in moving within town, or at least entertaining a move to a less flood-prone place in town, definitely is higher among these people that are really seeing the effects of routine chronic flooding. We also asked this question, but for moving outside of Carolina Beach in North Carolina. So elsewhere in the state, but outside of the town. So this is the exact same results, just for this question of within the state, not within the town. Here, you do not see as much of a shift in this right-hand panel. It's still a little bit, it's still like different from these 3, but certainly not the modal shift that you see in this one. And so people are clearly more willing to entertain a local within town move, which is very much consistent with everything we know about residential migration patterns and preferences. The last piece on impacts that I'll mention is related to water quality. And so this was actually health and safety concerns from water quality. So specifically the floods creating, like the floods mobilizing contaminants in the water. was the third most often reported impact for based on our survey. And two of our colleagues at NC State, Dr. Natalie Nelson, Dr. Angela Harris, have been leading an effort to understand how this type of flooding that's chronic but not as extreme might be affecting public health. And the main concern here is that due to the proximity to sewage lines, this type of flooding is actually mobilizing contaminants from those sewage lines and bringing them to the surface where they might come in contact with people. So their student, Megan Carr, led a sampling campaign in Carolina Beach last summer. They sampled at each of these dots. The red dots are places where they sampled the floodwater themselves, the floodwater itself, so the water that had come up through the drainage system or overland into the road. And the blue dots are where they took marine water samples. And they sampled for the marine fecal indicator bacteria and Enterococcus. They did this on 3 different flood days in 2023. So those are the different shades. Floodwater is not regulated. So there is no water quality standard for floodwater, but there is a water quality standard for recreational waters. And that recreational standard is this red line. It's 100 most probable number for Enterococcus in 100 milliliters. These are all the sites they sampled. And you can see that at every site, there was a sample that exceeded this recreational standard. And in fact, this is a log scale. So at a majority of the sites, there was a sample that exceeded the recreational standard by a factor of 10. And so these results we have been in communication with the town and with other local governments, as well as the state of North Carolina, because there's no regulation, but at the same time, these are relatively small floods that people can and do walk through, or kids may jump in because they look like puddles. And so in some sense, these types of floods may pose a really different health risk than, say, extreme hurricane floods where people might more naturally try to avoid the water. Okay, so to sum up in this section, we see really widespread disruptions to daily life from chronic floods, affecting everything from school, work, social activities, to even concerns about public health. And so we have ongoing work trying to understand how those water quality results relate to risks to human health, as well as a lot more work to dig more deeply into these survey results and see how these impacts are manifesting. Okay, my last section here is on working with communities to adapt to this type of flooding. And I'll be pretty brief on this part, I think, because it's mostly still underway and ongoing. In that survey that I mentioned in Carolina Beach, we ask people to rate their levels of support for different adaptation strategies. And so here are 2 snapshots of those results. On the left is their level of support for removing infrastructure, houses and/or roads from areas that frequently flood and restoring wetlands. You can see it's actually quite evenly distributed, which is not what I expected. I actually expected to see more opposition for something like this, but it's quite evenly distributed with a little bit more respondents in the opposed and strongly opposed category. On the right is the same set of responses, but for installing stormwater pumps. And you can see that that has lots and lots of support. Everyone, for the most part, is on board with doing that. What we're doing now is working with the town and town officials and a smaller group of residents to take these results and formulate potential adaptation strategies, things that the town might pursue doing in specific places around the town, and to understand what impact that might have on their flooding today and in the future. And to give you a sense, one of the things that comes up in conversation all the time, especially with residents, is the need for higher bulkheads. And so using Thomas's model, we can actually put in higher bulkheads and see what happens under different conditions. So on the left here is an example of a flood event looking at including both tidal and atmospheric forcing at present day sea levels. You can see flooding along the north side and running down Canal Drive here. If you add higher bulkheads, that does in fact stop the flooding from right here, from this north side, and from running down Canal Drive at present day sea levels. When you go to 2050 sea levels, the water finds a way, right? So water in this case is coming down from the north side of Carolina Beach where there aren't bulkheads, and then just propagating south downhill all the way down where we see it today, essentially. And the other thing that bulkheads doesn't mitigate is compound flooding. So here we add to our tides and our atmospheric forcing rain at present day sea levels. And you can see that bulkheads have really no effect whatsoever on reducing that type of compound flooding. And the goal of, I guess, one of the goals of our series of workshops doing this community engaged modeling with residents and officials is to try to surface some of these challenges and trade-offs where some adaptation strategies will be really effective, but only for certain types of flooding and only for certain time periods. And to see if we can formulate responses that are both appealing to the people who live there that would have local support, but also put them in a position where they're going to be actually effectively mitigating flooding for decades into the future, assuming that these are going to be fairly large investments. Okay, so to sum up, when it comes to how often is it flooding, we find that tide gauge-based proxies are not accurate measures of what coastal residents are experiencing. And this is due to some places being far from tide gauges. It's also due to rain and stormwater infrastructure not being captured in those ocean-based proxies. But the relative importance of the different pieces, the different drivers, varies from place to place. Coastal residents in North Carolina are absolutely already feeling the burden of this type of flooding. I think when we share numbers with our flood numbers with people who live on the coast, they're not surprised at all. And so to them, I think it's more that we're finally measuring something that they have seen and known and lived with for years now. And many of them recognize that it's getting worse as well. And so I think there's a very high urgency to understand how it's affecting these different parts of their daily lives. And then, of course, to figure out what we can do about it. And so through these community engaged collaborations, we're hoping to be able to identify some adaptations of interest and give communities evidence they need to understand what is going to work well for them in the future. The last thing I'll note is that all of our data are publicly available in real time. So you can scan this QR code or go to these URLs. These are all location-specific URLs. And you can see the pictures that we've taken. You can see the water level data and use it yourself. We do have a bunch of people who have contributed to us being able to do this work, and a lot of collaborators who are using the data. And we would love for the data to be used more widely. So please don't hesitate to reach out if you think it could be useful to you. And thanks for listening. I will stop there. Okay.
Hey, thanks very much, Miyuki. Do we have any questions? Yes. Yeah.
Put one in the chat.
Okay. I'm not sure who came first.
I'll look at the one in the chat first, and then have there been indications or indicators whether and how the real estate value and flood? Yeah. I guess so. I'll first answer from a like research overall perspective. I think from in the economics literature overall, I think there are some indications that in the past few years, in some places, real estate markets are starting to respond to chronic flooding. So the extent of, I guess, like, I would say not hurricane related risk, but the just being very low lying and experiencing water on the roads regularly. We have not tried yet to look at that in North Carolina for a few reasons. One, it's been a lot of work in itself to measure the flooding. So we're trying to do that well first. I think it's very difficult to understand exposure well, because we have households in our data where they don't flood, but they feel themselves to be very affected because their road to school or to work is affected. And then on the other hand, we have households where I think their property the road outside their house may flood regularly, but if they're retired and they feel like they can schedule their errands around high tide and so forth, they actually report feeling less affected. So we're trying to nail down, we're using our survey data right now to actually look at the geographic variation and distribution in our responses, and then use that as our exposure measure to then look at potential things like property value impacts. So we have not tried to do that in North Carolina, but I think that from a broader research perspective, it does look like maybe just if you look at recent data in some places, it might be starting to be priced in.
Thanks.
Yes. Phil?
What I didn't understand or catch how you were modeling the water entering that neighborhood. It might have been Carolina Beach, I'm not sure. Yeah, how is that done to see the effect of seawalls, things like that?
Sure. I did not talk about that at all. So it's AdCirc coupled with 3DI. And so we use AdCirc for the boundary conditions, the ocean forcings, the wind. And then Thomas built a 3DI model that includes all of the stormwater network, like all of the stormwater infrastructure in Carolina Beach, and the elevations of the different aspects of stormwater. It also includes like whether the outfalls have backflow preventers on them. And so really high resolution. And then we spent probably the last year calibrating that model against our actual sensor measurements to make sure that we were capturing things pretty well. And we're pretty well calibrated at this point. So that's, I guess, I'll say that Catherine and Thomas are leading that. So they're definitely the people to talk to for more detail. But the basics of the model is AdCirc plus 3DI with a lots of local info.
Any other questions? Yes.
Do you have a vision for using SAR? I mean, it seems like a great idea, but the SAR, any kind of satellite measurement is very infrequent, but I could see how it can be really useful here if you've got years and years of it and you really can just gradually capture the relationship between the tide gauge and the water depths on the streets, or even just capture enough high tides to really map the frequency of flooding or something like that. Seems like a great idea.
Yeah. I think we're optimistic about being able to use it at times when we know there's flooding in one place to be able to get the full spatial extent when we don't know, right? When we only have one sensor and one camera in that area, what was the extent of flooding? I think that feels feasible also because where we have sensors, we have a pretty good sense of not rain events, but with tides, when stuff is going to flood. So we can task the satellite and collect that data and look at it that way. I don't know. It's certainly not a substitute for the sensor data in the sense that our town partners will just like pull up our pictures to see what's going on and see if they need to go close the road, right? So like remote sensing is not going to replace that. But I think our goal is to be able to, for events that we know about, be able to get spatial extent more so than we currently can with the limitations of our in situ data. And then again, like you said, I think if you do it steadily over many, many years, you could get like a frequency count, right? Or you can use it to calibrate a model the way that we have. But it's still early days. So I'm actually like, I still honestly don't know if it's going to be able to get like the street scale stuff that we are seeing, especially in an urban built up setting. That's still very much up in the air, I would say. But I think it's, I mean, yeah, we need a way to scale, right? We can't put sensors everywhere. So it's definitely a necessary piece of the puzzle if we want to study this in other places.
So I had a question about the future projections. So I was wondering if there is more information that the climate, if you had that information from climate models, like how that might help to make the future projections or improve adaptation strategies.
Mm-hmm. Yeah, that's a great question. Another one I didn't really touch on. We have really only, I would say in terms of future changes that might occur, the only one we've really grappled with at all at this point is sea levels and just being able to modify that in a model. And even at that point, taking pretty much static, right? Taking a certain amount of sea level rise from current to future time. So for our community engaged modeling workshops, we do intend to look at 2030 and 2050 under different projections and see what would happen, but we haven't factored in really at all potential changes in rainfall, for instance, over that time period that would also affect how often certain combinations of conditions are occurring. So that would be, I think,
NOAA projection, or what silver forecast are you using?
which one? Yep. We are using, I can go back and look at it. We're using NOAA's projection for the Southeast, and let me see, we have for 2020 to 2050, our main one that we've looked at so far is 25 centimeters of sea level rise for, yeah, over the 30 years. So we can, one of the things that we intend to talk to our community partners about is actually which scenarios would be most useful to explore, moving away from just the intermediate forecast. But I think that's, I guess there's a heavy like social consideration, right? Like kind of willingness to engage or interest in engaging with the high end extremes versus the intermediate to lower scenarios. So we'll see.
Any other questions? Well, I guess we can stop there. There are no other questions. So thanks again, Miyuki.
Thanks, Patrick. Thanks for the questions.